3v squared minus 31v plus 67. And when we do regular long division, we have to use the factor, not the actual zero. For synthetic division, we need the zero, right? But for long division, we use the factor v minus 7. So I need to make or multiply v minus 7 by something to get 3v squared. So I'm going to multiply it by, let's see, 3, and I need a v. So I'm going to use a different color. 3v will give me my 3v squared. 3v times minus 7 minus 21v. Then I have to subtract the entire quantity. Okay, these eliminate. So I get negative 31v minus a minus, so it makes it plus. 21v is going to be a negative 10v. Bring down my next number, plus 67. So I'm going to take v minus 7, multiply it by something to get negative 10v. So I need a negative 10. Negative 10, negative 10v. Negative 10 times negative 7. Good. I'm going to subtract the entire quantity that I just created. Negative 10v minus a minus 10v eliminate. 67 minus 70 is minus 3. So my answer, 3v minus 10. And I have a remainder here of 3, and I put it over the divisor, v minus 7. Questions? Okay, synthetic division, we just use the coefficients of our dividend, and the divisor, this time we need the actual zero, okay? So what we do is we take this k minus 6 and we set it equal to 0, right? Add 6 to both sides. So did we do this yesterday? Oh, we did both of them yesterday? Do you want me to do one just for those students that are paying attention now? Okay, so my divisor is 6. Let's see my coefficients of the dividend. I have 1k to the 4th. I do not have a k to the 3rd, so my coefficient has to be 0, right? You know what? If we got time, I'll let you do a problem. Negative 36 for the k squared, positive 8, and then a minus 48. Going to bring down the 1, multiply it to the 6, and I get 6. These I add. 0 plus 6, 6. And I start over again. 6 times 6 is 36, plus a negative 36, 0. 0 times 6, 0, plus 8, 8 times 6, 48, minus 48 is 0. That's an 8. Okay, so let's see, I'm down to, started with 4, so I have a 1k cubed plus 6k squared. And this is a 0k to the first. You can put it in there if you want. And then I've got a plus 8. No remainder. They're not asking us to go any further. They're just asking us to do one division. So I'm done. That's an 8. Yep. Okay. Next page. Did I do any of these? Um, yeah, let's do number 14. So what's my divisor in 14? Not be careful. Negative 9, right? Because you have to set that equal to 0 and then solve for n. Okay, my coefficients. They're good, good, good. Bring down the 1. Multiply it to negative 9. Negative 9 plus 1, negative 8 times. Oh, wait, I'm sorry. That's 13. My fault. I was looking at the 1. It'd be 4, right? Almost made a huge mistake. It's like accounting. You got to go back to the beginning of the problem if you make a mistake. Okay, 13 minus 9 is 4. 4 times negative 9, negative 36 plus 39, 3, 3 times negative 9, negative 27. So this is going to have a remainder, right? Negative 1. So I started with n cubed. So I have 1n squared plus 4n plus 3 with a remainder of negative 1 over my, and now I got to use a factor, n plus 9. Okay. All right. FTA, Fundamental Theorem of Algebra. Now, I always thought this was fun until we started analyzing graphs. I thought it was much, much funner. I think it's the funnest, to tell you the truth. How do you determine how many solutions a polynomial has? Well, how do you know the number of zeros? You look at the degree, right? Degree of the highest degree, I should say. Highest degree or the degree of the polynomial, however you want to look at it. Give me an example of a polynomial with 4 solutions. Don't make this difficult. X to the 4th, right? That has 4 zeros. Okay. Now you can add a whole bunch of stuff to there. That's fine with me. I don't care. But this one has four solutions. Use your calculator. Find all rational zeros. So all of those zeros that cross the x-axis, right? The x-intercepts. Then use that to reduce with synthetic division. Find all other zeros of the polynomial. You ready for this? Like I said, this is fun. Not as fun as analyzing graphs. So, wow, we got a lot of sneezing going on today. Even my last class. Okay, so I'm gonna go to my handy dandy calculators, right? So I gotta put in our polynomial, x cubed minus x squared plus 25x minus 25. Graph it. And it looks like, how many real zeros do I have here? I only have one. Okay, I only have the one x-intercept. Hopefully, when I go to the chart, it says 1, 0, so I don't have to do the second trace. So I'm going to go to my table, and sure enough, at x equal 1, it is y 0. So that is one of my zeros, the number 1. Now, you've got the synthetic division over here. If you're used to putting it underneath there, by all means, go ahead. So here's our 0 we're going to use for 1. So what does that mean? What are the other two zeros? Imaginary, right? Okay, coefficients of my polynomial. Positive 1, negative 1, 20. Thank you. Thank you. So I'm going to bring down the 1, multiply it to get, add it to negative 1 times 1 plus 25 times 1 minus 25. Look at that. Okay, so I'm left with, yeah, I'm going to leave this x to the first out and just put 25. Can I factor that?
No.
Why?
Yeah, can't you do x plus 5?
Ah, that's what I was looking for, right? X plus 5, x plus 5. And let's just check this, okay? Why won't it work? It's not a difference of squares, it's a sum of squares. When you FOIL this back out, I get x squared plus 5x plus 5x plus 25. Combine your middle two terms, I get x squared plus 10x plus 25. This does not factor. And again, these would be real zeros, right? At negative 5. We know we have imaginary solutions. And the only way we can get that is with quadratic formula or completing the square, right? And that is Aiden's favorite. So this doesn't work. We're going to use the quadratic formula. Let's see, our A is 1, our B, and our C. Okay. So x equals, sorry, negative B
times 1, right? A, and then times B. I mean C. And then divide by 2 times 1.
Awesome. Thanks, Kaluna. All right. I'm going to do the square root off to the side here. Square root of, well, I don't need the 0 squared. I know it's 0, so all I need is put the minus sign there. 4 times 25?
100.
Yeah. 4 quarters make $1, right? Actually, the square root of 100 is a perfect square. Yeah. 10, good. And square root of negative 1? I'm going to replace it, that whole square root with that, okay?
I don't know.
What?
What would be wrong if you took x squared plus 25 and then just set it equal to 0 and go from there?
You could do that.
Bless you. You're welcome.
You
Why
do.
why do that?
Because I like to see you guys work.
You didn't
Asher's gonna give us some tips.
Yeah. But you guys need to figure out these things by yourself, not somebody telling you stuff.
No,
I know he is. But if you guys don't learn those things for yourself, you'll never learn. Okay? And if you always have somebody telling you, a shorter way of doing it, yes, there's a shorter way of doing this. You learned a shorter way of doing it. I taught it to you. Yes, I did. When we were solving different methods of factoring. Yeah. I even called it something. But you guys need to figure it out yourself, okay? Otherwise, of course, I'm going to use the longest and method that's guaranteed to work. But this other method works, and let them figure it out. Then I would appreciate that. Okay, so I have negative zeros I'm going to leave out, so I got my plus or minus. 10i divided by 2. 2 can actually go into 10 5 times. 2 goes into itself once. So I have plus or minus 5i. Right? Those are my other 2 zeros. So I have 1, 5i, minus 5i. You can write it either way. Doesn't matter.
Well, that seems pretty accurate.
Did you tell him?
No, he didn't.
No.
Thomas is guessing.
It's pretty obvious.
Square root 25 and add the I.
And it has the I.
All right, let's have the funnest of the fun of the year and analyze some graphs.
Did you do this one? Oh. Flip it over. Not for you.
Okay, you ready? We're going to go ahead and sketch the graph of this. So I need to put this in my y equals.
He said I'm not sick.
So I got 2x cubed minus 8x squared plus 2x plus 5. Going to graph it. Now I need to sketch this on my little graph here. So I'm going to go to my table, get some points. See, -1, -7. I can do that one. 0.5, 1.1, 2, -7, 3, -7. And I got a feeling that my calculator is rounding these, so because I shouldn't have a flat line there. And 413 is way up here. All right, let's see if I can draw this. It's coming up, increasing, right? Hits the turning point, down, like this. Look good? Not too bad. This minimum here. Our calculator has to be rounding this off. This should be a turning point. All right. So the first thing we need are the x-intercepts or the zeros. Now here's where you got to and sign in and out. Sign out, then sign in when you come back in. All right. So our zeros here. Let's see. Gonna have to second trace. 0, enter. Left bound, enter. Now I'm doing the zeros, so I'm not doing the mins or max. Right bound, enter, enter. My first zero is -0.6. My second zero, second trace, 0. Isn't this fun? Fun. Left bound, right bound, enter. It's like playing video games, isn't it? 1.1, comma 0. And then I'm going to shoot this invader over here, get this other 0. See, like video games? Get it? Get it? Get it? Space Invaders. What do you guys play? We play X Cube. That's what we play. Second trace, 0. You guys are not seeing the humor in my funner. If you see the humor and make this fun, it'll be the funner stuff. All right, my last 0, 3.5. Okay, there's my zeros. Now I need my max and my min. Okay, my max. Second trace. Go to max. There's my max. I got to get to the left of that. It's like Mario going down this path. Enter. 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 0.1. Boy, these are some great numbers, aren't they? 0.1, 5.1. Or you could put the 3 there. That's fine. Minimum. Oh boy, now he's going to save the princess. Minimum, like video games, videos. Enter. 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 So I got 2.5. -8.8. Okay. So this is what breaks up my x-axis to increasing and decreasing intervals, right? So let's go ahead and put those lines in there, my x lines. I got 0.1, almost the y-axis, right? 0.1. X equal 0.1. And this don't even cost you anything. This is free. You don't even have to buy a video game or anything. You could just watch my video. You can even play with your calculators. It don't cost you anything.
is a very bad video game.
2.5, 2.5, 2.5. X equal 2.5. So here's my intervals, right? I got from infinity, negative infinity, to 0.1. Then I've got 0.1 to 2.5. And then 2.5, positive infinity. In fact, I'm going to write those intervals down. Negative infinity to 0.1. Then I've got 0.1 to 2.5. Then I've got 2.5 to positive infinity. So here's where I start my graph down here at negative infinity, right? So I start my graph, and I'm going to go up until I reach 0.1, right? So this is increasing here. Then it's going to, from 0.1 to 2.5, decrease, and then increase back up here, right? So if I do all that, all I have to do is just copy it down here, right? Copy and paste. See, now you're into computer programming, copy and paste. All this fun stuff in one problem. So increasing negative infinity to 0.1 and 2.5 to positive infinity. And it don't even cost you anything. That's the best part. We should put a union symbol here. No, you don't. We'll provide one for you. If you really need one, I got an old one you can have. You could throw away your Xbox and PlayStations, and I'll give you that old crappy calculator. I mean, really nice classic calculator. Decreasing 0.1 to 2.5. Okay, end behavior. Guys, remember end behavior? As x goes to the left, let's see, left, y goes to negative infinity. Good. As x goes to positive infinity or to the right, y goes. Look at that. Oh man. You guys should feel bad and like almost want to pay me for having so much fun.
After synthetically dividing, I mean, could I use that just to get some zeros?
Your method? What this?
Synthetic division. So basically, the polynomial get the zeros, and then everything else after that just graphing those.
As long as they're real zeros.
Okay.
Don't forget, if they're imaginary, it's a different axis.
But that wouldn't show up for graphing it.
Your imaginary zeros would not show up on your calculator. Okay. So you wouldn't be able to get the imaginary zeros. Huh?
What if I just don't use the imaginary?
Um, in mathematics, you have to. Okay. They're there. I know what you're saying. In